So in this video we will study about the entropy of phase changes, how entropy changes according to phase, and which phase will have more entropy, which phase has less entropy. So as per previous videos, we have already studied that for the entropy, if we have to calculate, it would be equal to Q means heat involved and divided by T, or we can say that delta H or change in enthalpy over T. And what are the phase change means? Phase change means if we are going to convert solid into liquid or liquid to gas or vice versa, right? Anything. So for this type of changes, how the entropy will change. So where Q or V, E or EV means reversible process. So these are all reversible process. And T for temperature in Kelvin, Q here capital Q or small q, both are same thing. Heat, which is in joule per mole, and S is entropy, joule per mole Kelvin. Delta H is change in enthalpy. Here is this phase diagram that shows the entropy is increasing, means randomness is increasing, and here temperature is increasing on the x-axis and y-axis is entropy is increasing. So first phase is like a solid, and then liquid second phase, and third phase is the gases. So this curve, if you see, this is called the phase change curve. So as we are increasing the temperature, basically this red curve shows that entropy is increasing, and at the particular phase change state there will be sharp increase in the temperature, and then again at particular temperature, which is like a melting point, solid melt into the liquid. So at exactly on melting point, entropy changes very sharp, and then it will keep going slowly increase as the temperature will increase, and then when liquid goes to gas, basically it is like a boiling point, right? So here we have melting point, this region is vertical line, and this another second vertical line is a boiling point. So it's exactly on boiling point, entropy increases very fast, and then again slowly increases as the temperature increases. So what is going on at this point here, where the temperature is 0 and entropy is also 0? So for this particular point, I would like to remind you that this is the state where third law of thermodynamics came, that says the entropy of a pure crystalline solid, pure crystalline substance at the absolute zero temperature is 0. So right, so this point where the temperature is in Kelvin and 0 degree Kelvin means absolute temperature, and entropy will be 0. So this point is the third law of thermodynamics. This point is third law of thermodynamics. TD means thermodynamics. So where entropy of pure crystalline solid will be 0 at 0 degree Kelvin. Next is how we are going to change the phase, and how this entropy changes. So if we are converting solid into liquid, the process is called fusion or melting, and going back liquid to solid is freezing. Liquid is going to be gas is evaporation, and gas is going back to the liquid is condensation. Gas converting back to solid is deposition, and solid is going directly into the gas without liquid is sublimation. So in these process you can see that the dark arrow, dark brown arrow, or like I will say that fusion, evaporation and sublimation. In these process, delta S means change in enthalpy is more than 0, means positive, right? So enthalpy is increasing, sorry, entropy is increasing. Delta S means change in entropy. Randomness is increasing as we move from solid to liquid or liquid to gas or solid to gas. Entropy increases, and this light brown color shows the condensation, freezing and deposition. Entropy decreases, or the sign of the entropy will be negative, right? So we'll see one example that predict the entropy of a system will increase or decrease. So here you can see hydrogen and oxygen are reacting to make water. So gas are the reactants and liquid is the product. And if you remember that delta S, how we calculate delta S. So change in entropy means S final minus S initial, or product S product minus S reactant. So here product is liquid which have less entropy and gases have higher entropy. So that is why delta S will be less than 0, means the sign for the delta S will be negative. What about the second step, where liquid water is going to be gas? So here entropy is increasing, water have less entropy, so delta S, so product have higher entropy, or final stage have higher entropy than the reactant or initial. That is why delta S will be more than 0, or we'll say the sign for this will be positive. And what will happen in the third condition, barium hydroxide solid is reacting with the carbon dioxide gas, it is giving barium carbonate solid and liquid. So basically solid have very low entropy, barium carbonate also have low entropy, carbon dioxide gas have higher entropy, liquid have also less entropy, right? So all entropy is decreasing here, and mostly reactant side we have higher entropy. So delta S for this condition will also be less than 0, and the sign for this reaction will be negative, because reactant have higher entropy than the product, so the sign will be negative. So this was the entropy change for the state of matter. In the next video we will study about the standard reactions, standard conditions.